External departure is approved.
339, wind receiving, proceed direct Santa Monica, depart WRD 250.
As air traffic increases, greater demands are placed upon aircraft communications.
3 Romeo Delta. Position and hold behind
Up until now, introducing new communications technology to aircraft has meant adding more equipment to systems never designed to take it. But the successful integrated modular approach to avionics systems has shown that there's an alternative. An integrated modular communication system, which would increase flexibility while reducing weight and cost. It would also help meet the need to manage safely increasing numbers of aircraft in the limited airspace. It would support the future expansion of an aircraft's data capacity. And it would be designed to meet the stringent aeronautical requirements that include security, reliability, redundancy and flexibility. Thales UK has been working on such a system within the EC-funded project Sandra, with other leaders in their own fields, both in industry and the academic world. The results so far have not been simply an evolutionary development of the existing architecture, but a radically changed way of approaching communication systems in civil aircraft with new architecture. An integrated and modular system that facilitates the move towards the Sandra vision of an integrated aeronautical network. Aircraft need to communicate using a number of different radio waveforms, from VHF to high-rate satellite communications. The key to the integrated modular approach is to separate the radio functionality into its constituent parts. The front end covers antennas and all their associated equipment. The transceiver is the analog part of radio technology with some digital elements. And processing covers all the remaining digital aspects. In the past, each type of radio in an aircraft had all three parts in the same unit. But weight and money can be saved by using common processing technology. And even allowing for redundancy, there's a significant saving. In addition, modern high-speed digital links mean that there can be greater physical separation of transceiver and processor. This can lead both to improved radio performance and reduced installation costs. The system in the aircraft is completed by an integrated router, which connects to all the aircraft applications. Radio resource management software within the system chooses the most appropriate link to the ground, where all communications are increasingly based on internet technology. These designs are not simply theoretical. A proof of concept demonstrator has already been built. It consists of two common processing platforms, providing both the processing power and redundancy. 3 transceivers and 1 receiver. 2 for standard current radio systems and 2 oriented towards the future. All 4 are connected to their respective front ends. Both processors are connected to the integrated routers, again supporting redundancy. And links within the system are either through fiber optic cables or Ethernet. This demonstrator has not just been built, but has been tested in an aircraft environment. It's shown that the separation of processor and transceiver functionalities and the use of a common processing platform works, and works well. As does the use of high-speed data links, and the necessary concurrent support of multiple end-user applications, together with incorporating legacy equipment such as VHF. The system's modular structure means that it can be reconfigured much more easily than now to accommodate new technologies and waveforms. At the same time, the successful unification of data traffic around internet protocols will allow distributed services applications to be modified as needs arise in the future. The system development by Thales UK and its partners so far has therefore laid down substantial building blocks for a new and more capable system of resource management in aviation communications.
As a result of the groundbreaking research that we have achieved in this Sandra European Research and Technology Programme, we have absolutely laid solid foundations for a future generation of aeronautical communication systems which will be good for 20 years and beyond.